Hello primary 6 students. Today we will start lesson 2 in unit 2, dangers of electricity. We knew from lesson 1 that electricity or electric current is the flow of charges through electric wires or any good conducting material. We also knew that the pathway of this electric current is called an electric circuit. A simple electric circuit consists of three main parts, which are the battery, the electric wires, and the lamp. The battery here is the source of charges or the source of electric current. The electric wires is the part where the current passes through, and it also connects all the parts of the circuit together. The lamp here is the tool that converts the electric energy into other form of energy, which is light. We also knew that the current to pass, it has to pass in a closed circuit without any gaps, and all the parts of the circuit are connected together. Let's take an example. The lamp in your house, how does it light? It has to be a part of a circuit. Does the lamp in your house depend on a battery as a source of energy or electric energy? Of course not. The question here, how does the electricity reaches our homes? There is a place called the electric power stations where huge amount of electricity is generated, and then it's going to be transmitted to other places like buildings, streets, whatever, and this happens through transmission lines or electric cables. As you can see in the figure, they are hanged up over electric towers, and because they are characterized by being very strong or of high voltage, they are first passes through transformers that decrease or lower this voltage to be safer for our use and more convenient for our daily use. Let's have a closer look on these electric cables and see what it's made up of. The electric cables are made of two parts or two layers, the inner one and a covering from outside. The inner part is made of a good conducting material like copper metal, because this is the area where the current passes. It has to be a good conductor of electricity one. While the outer part, it has to be made of an insulating material like plastic or rubber to prevent the passing or the leakage of this electric current to the surroundings, and this is for safety, to avoid any dangers of electricity that we are going to talk about in this lesson. Okay, so we know now that are two types of materials, good conducting of electricity and bad conducting of electricity. There is a simple activity here to discover or to compare between electric conductors and electric insulators. We will form an electric circuit as shown in the figure, a simple circuit. As we said, we need electric wire, a battery, a lamp, and then bring any materials that you want to test for its electric conductivity. We can use a wooden pencil, a coin made of copper, an iron nail, a piece of plastic, whatever. We have to put this object between the two wires and make it a part of a circuit and observe the lamp. If the lamp lights up, this means that the current was able to flow, to move through the wire and through it, so the lamp will light. But if the lamp did not light, it means that the current was unable to complete its path, and the lamp will not light as a result. Let's see in figure 1. As you can see here, the lamp lights up because the key, it's made of copper. It's a good conducting material. It completes the circuit. It allows the current to pass through, so the lamp will light. But in figure 2, the wood made a gap inside the circuit. The circuit is now an opened one. The current is unable to flow anymore, so the lamp will not light. From this experiment, we conclude that there are two types of materials, again, electric conductors and electric insulators. What are the electric conductors? They are materials that allow the electric current or the electricity to flow through, like metals, copper, iron, aluminum, lead, as we studied in lesson 1, steel, whatever. And bad conductors of electricity or electric insulators, these materials, they do not allow the electricity to pass through them, like wood, plastic, rubber, cloth, etc. Again, the electric conductors, they are a part of the circuit. They complete the circuit, make it a closed one. While the bad conductors, they make gaps in the circuit. They make the circuit opened, so they do not complete the circuit and the electricity cannot flow through. Okay, more examples on electric conductors and insulators. Here the conductors like aluminum metal, steel, gold. Insulators or electric insulators like wood, plastic, rubber. Okay, so we can observe that the heat conductors we studied in the first term are similar to the electric conductors now in the second term. But here we have an exception here. The exception here is water. We knew from the first term that water or any liquid is a bad, except mercury of course, is a bad conductor of heat. But it's found to be that the water is a good conductor of electricity. And because the human body contains mainly almost 70% water, so the human body is considered to be a good conductor of electricity. Our body is mainly made of water because this water is important for our vital activities inside the cells, and also it helps in the blood formation. So a question here, for example, if I asked give reason why the electric wires are made of copper, the answer is because it's a good conducting material, or it's an electric conductor. It allows the current to pass through. And another question, why the electric wire is covered with an insulating materials? Why? Because it doesn't allow the current to pass through, so it avoids any shocks or any dangers. Okay, now time for you. What do you think? These are examples of some materials. Can you figure out whether it's good conducting or bad conducting materials? Yes, the aluminum is a metal, so it's an electric conductor, while rubber and wood are electric insulators. Okay, now let me ask you a question. Do you think that the electricity is something useful for us or harmful? Well, it's both. We can't imagine life without electricity. We need it every day to light up the houses, to operate the television, to charge our mobile phones. Electricity is very important in our daily activities. As you can see, many devices or appliances at our homes depends on electricity in order to work, like the washing machine, television, microwaves, boilers, etc. But if we did not deal with electricity very carefully and pay very good attention while using it, it's going to be something harmful or dangerous. Electricity is something useful unless we use it with an improper or a wrong way. In our lesson today, we are going to talk about those dangers of electricity. There are two types of dangers or injuries in this lesson. We have the direct injuries and the indirect ones. I'm going to start with the indirect injuries because the rest of the lesson is talking about the direct injuries. Look at those pictures in front of you. You can see some persons or workers. They are standing on a high place and they are dealing with electricity. They are maybe fixing something or doing something with the electricity, and by accident, for any reason, the electricity reached their bodies, or they got an electric shock. So due to this shock, the person will fall down from the high place, for example the top of a ladder, and after he falls down he's going to suffer from another problem. I mean, he got an electric shock at the beginning, and after falling down he had another problem, which maybe he broke his arm or his leg, or maybe it was something more serious here that may cause death. Okay, so the example here on the indirect injuries is falling from the top of a ladder due to an electric shock. Okay, now let's move to the direct injuries. We have three examples on the direct injuries, which are the electric fire, the electric shock, and the electric burn. Let's start with the injury number one, the electric fire. Why does the electric fire occur? What are the factors or the reasons that help in causing the electric fire? Electric fire happens due to a rise in temperature, the temperature of the wires or the temperature of the machine itself. So the machines here which are risky or we are afraid of them are the machines that generates heat. What are examples of the machines that generates heat we use in the house? Like, for example, the electric heater, the electric iron, the stove. Any machine that generates heat is something dangerous because it produces heat, and if this heat increased up to a certain limit, it may causes fire. Okay, so what are the causes of the electric fire? We have three reasons. Number one, placing or putting flammable materials close to these machines. I'm talking about the electric machines that generate or produce heat. Okay, what are those flammable materials? Flammable material means materials that easily burn. They easily catch the fire, and they burn very easily and fast. Like, for example, the curtains, the carpets, the furniture, anything made of the cloth. So if, as in this picture, if the electric heater is placed beside a couch or beside a piece of furniture, and this electric heater is connected to the electricity, it keeps working, it keeps generating heat. If this device heats up too much, it will cause the electric fire to happen and catch the flammable materials around, and the fire will spread. So here we must not put these flammable materials close to any machines that generate heat. Okay, if we are ironing clothes, we should not keep the electric iron close to the clothes too much, that they may cause fire. Okay, look at this example here. In order to avoid the electric fire, we should not keep the machines that generate heat very close to flammable materials. Number two, or the second reason that causes electric fires, is not disconnecting the electricity from machines that generate heat after our use. After we use any machine that generates heat, you have to disconnect it. Remove the wire from the socket, because as long as the wire is connected, the current keeps moving and the heat keeps produced, or a large amount of electricity is generated, and as we said, this causes a rise in the temperature of the machine and the wires, and they may lead to fire occurrence. So please do not forget to disconnect the electricity or the current from the machines that generate heat. It's not a must to disconnect all the machines after use. I'm mainly talking about the machines that generate heat, as you see in the figure, like the heater, like the toaster, like the electric iron. Okay, this is the reason number two. The third reason that causes fire is plugging or inserting more than one machine in the same socket. Most of us use this extension cords or this multi-adapter that allows us to operate more than one machine at the same time using the same socket. Of course, this is very dangerous because this causes an electric overload. Electric overload means a large amount of electric current passes through the wire, and the wires maybe they will not overcome all this amount of electricity. They heat up and they burn. They cause the fire. So if you need to use more than one machine at the same time, try to use different sockets. Do not plug them all together in the same socket. Again, this causes an electric overload, and the wires will heat up and their temperature rises too much that they burn and causes the fire. Again, what are the causes or the reasons that leads to the electric fire? Placing flammable materials, putting flammable materials like curtains, like rugs or carpets, like clothes, close to the machines that generate heat, like heaters, like the electric irons. And reason number 2 is not disconnecting these machines from the electricity after our use. Reason number 3 is plugging more than one machine in the same socket. This causes an electric overload. The wires heat up and they burn. They cause fire. Okay, so now we conclude that we have two types of fires, the regular fire and the electric fire. How do they differ? They differ in the reasons causing the both types of fires and the way they are put off. The electric fire, they are caused, as we said for the previous reasons. How they are put off? How do we extinguish the electric fires? Can we use water? Of course not. Water cannot be used to put off electric fire because, as we said in the beginning, the water is an electric conductor, is a good conducting material. So if you add water to electric fire, you are helping the current to flow more. The water helps the current to keep moving, and increasing the reason that's leading to the fire. Water is a good conducting material or good conductor of electricity, so it will increase the fire. So how do we put off this type of fire or fire resulting from electricity? The best solution here is to use sand. Sand is used to put off electric fire. This is why we sometimes see a bucket full of sand in labs or in some places. This is for safety in case electric fire occurred. While the regular fire, of course, this happens due to heat. The electric fire happens due to electricity, while the regular fire happens due to heat. So in order to put off the regular fire, we need a bad conductor of heat. And as we said before, water, although it's a bad conductor of electricity, it's while the water is a good conductor of electricity, it's a bad conductor of heat. So the best way to put off the regular fire is to use water. Water is used to put off the regular fire or the ordinary fire. A question here, what happens if water is used to put off electric fire? The fire, of course, will not put off and it will increase because water is a good conductor of electricity.